Hi, this is Kumaran. In the series of microprocessor and microcontroller, we will see about peripheral devices. Before going into this video, peripheral means supporting ICs because when we design a microprocessor based system, only microprocessor is not enough to develop a project, which means a working model. So for that, we need to have supporting peripherals. So in that, the basic peripheral is 8255, which is I/O device interfacing. Then the 8254 timer for time-related applications. Then serial communication interface, A to D, GPA converters. Likewise, many peripherals are there. Let us start with the basic peripheral 8255 in this. The 8255 Programmable Peripheral Interface PPI, which is commonly used peripheral in any microprocessor, microcontroller based system design. For example, when we use a traffic light interface or any motor interface or any many I/O device interface, this is a common IC. This is also designed by Intel 8255, that is Programmable Peripheral Interface, which is a 40 pin IC, dual inline package, same as microprocessor 86 size it will look like, but it is a very simple IC, a peripheral interface. Actually, what purpose the 8255 is needed when it comes to the microprocessor based system design? Look at this block diagram. There is a microprocessor which is 8086 or the Pentium processor, whatever we use for our practical applications. Then we will use some input devices like our keyboard, sensor, many input devices we can use. The same way for output device also, just like a monitor or LED lights, then some printer, plotter, some simple I/O devices we will use in a system. So to connect this input and output devices, we can connect directly also. Directly we can connect to the microprocessor. But when it comes to that direct connection, microprocessor has to monitor the input device continuously without executing any other instruction. The entire microprocessor CPU time has to be dedicated for input device to monitor whether any key has been pressed or not. The same way, if you want to control one LED, then the microprocessor has to continuously execute the same instruction to switch on, switch off the LED continuously. So in this scenario, the maximum time of CPU is wasted by servicing I/O devices alone. Then our microprocessor we cannot use for effectively many applications. That's why we are going for a peripheral device 8255. What the purpose of the 8255 here? Suppose microprocessor wants to read a key from the keyboard. The device is connected with the 8255. Then the 8255 is connected with the microprocessor. So the 8255 will monitor continuously the keyboard. Any key has been pressed or not. If any key pressed, then it will intimate to the microprocessor. It will generate one interrupt. Then the microprocessor will give the attention and read that key value. That's it. Then it will go back its main routine of any other task execution. Same way, suppose the microprocessor wants to switch on an LED, it will give a signal to 8255 switch on. Then the 8255 will switch on continuously until next time when the microprocessor tells that it will switch off. So only the microprocessor will initiate. Then the remaining thing will be taken care by the 8255 continuously. So the I/O device interfacing is very easy. At the same time, the processor time is reduced here for I/O devices. So only the time of switch on the LED, the processor will give the attention. Then it will go back to its normal programming execution or any other task execution. Whenever it wants to switch off, then only it will intimate. So the in between time can be used by the microprocessor for any other applications. That's what the main purpose of 8255 here. It is a peripheral. With the help of 8255, by using a microprocessor, we can control input-output devices. But only 8255, you cannot design the system. That's what, because 8255 doesn't have CPU like microprocessor memory, we cannot program this. This is programming in the sense we can assign the direction of I/O ports. That's what we can change with the help of the internal register content. That's what the programming. But microprocessor have a lot of things in it. As you know that it has CPU, programmable registers, So it can perform many other tasks. We can execute instructions. Everything is possible. So the entire system you might be understand clearly now. The 8255 will act as a mediator between microprocessor and I/O devices. That's the main purpose of 8255 here. Let us look into the 8255, how the pin diagram, how it looks like. The 8255, we have 40 pin IC. Already we have discussed there. 40 pin means 20 pin one side. So dual inline package. So in that, look at that, three I/O ports, port A, port B, port C, each 8-bit wide. So totally 24 pins are taken for I/O ports. Then 8 lines are taken for data lines, D0 to D7, which will be connected with the microprocessor. Then we have power supply and ground. So ground pin, then the VCC. Then we have two address pins, A0, A1. Then there is a chip select pin, read pin, write pin, reset pin. So totally 40 pins are configured here. So the entire signals are, entire 40 pins are as programmed. Let us discuss one by one in this next one. This is the black diagram. Black diagram, we can call it as architecture in case of microprocessor. Nowadays we will call it as architecture also. So here, the programmable peripheral interface, we have the three I/O ports as I discussed: port A, port B, port C. So the port A assigned that 8 I/O lines, 8 PA0, PA1 till PA7, 8 lines which are used to connect either input device or output device. Then the same way for port B also, but port C has two partitions. One is the lower port, another one is upper port, each 4 bit. So totally 8 plus 4 plus 4 plus 8, 32 lines are available as I/O devices we can connect. Any device you want to control with the help of microprocessor, that you can connect through this 8 lines. Sorry, 30. 8 into 3, 24 lines we can connect. Then the interfacing part, here the control part which will be connected with the microprocessor, D0 to D7, which is the data lines which is connected with the microprocessor. Whenever the microprocessor wants to control any device on the port A, it will connect the data through this data lines only. So you suppose it wants to read a keyboard on port B, that also through this path it will reach. So the microprocessor data lines are connected here, D0 to D7. Here there is a data bus buffer. In all the peripheral devices, we will have this buffer because the speed of the microprocessor and the speed of peripherals are not equal. The peripherals are always slow compared to the microprocessor. So to match the speed, suppose microprocessor is writing some data on the port B, which is connected on a LED. So it will take some time to read the data. So the interface time difference between the data microprocessor placed and till that the data is accepted by the 8255. So for that purpose, we will have a data bus buffer. This black will be available in most of the peripherals because it is simply a one-way buffer. It will hold the data temporarily until the device 8255 will take from the circuit. This data bus buffer. Then we have a read-write control logic. In this, we have read and write signals. Both are active low signals. That's why it is connected as bar, indicated as bar. Active low signal means normally 1. Whenever the signal is enabled, that time only 0. Suppose the 0 is enabled here, then the device will act as a read. So the write will be enabled, the device will write data on the ports. Then the A0, A1, these two pins are address pins, which will address the port A, port B, port C. Because whenever microprocessor wants to read or write a port A, it has to give the address through this. The address is for example, A0. It is both are 00. It will point that port A. So the internal device will connect the microprocessor data bus to the port A like. It will connect. Suppose it will. Suppose it is the next one. It is 01 means it will connect to the port B. 1 1 means 1 0 means it is port Z. 1 1 means control register. There is a control register here, group A control and group B control. So the address informations are very clear. 0 0 means port A, 0 1 port B, 1 0 port C, 1 1 control register. So such a way the microprocessor will identify out of 3 ports, then one control register. It will identify with the help of these two address lines, A0 and A1. Then we have a reset. Reset pin generally, when we reset a microprocessor, it has to reset the entire system. And that's why it is connected with the reset pin of the reset out of the microprocessor. Then the peripheral also will get reset. Reset means it will erase the internal register content. This group A, group B register content will be erased. Then it is becomes a reset, means start from the fresh. Then we have a chip select signal. CS means chip select. Simply the device on off control. Because the data lines, address lines, read, write, all signals are connected permanently with all the peripherals. In a microprocessor based system, not only the 8255, it will have multiple devices like. Yeah, that's why you can see the motherboard will have a lot of peripherals in it. So all the peripherals are connected each other with the microprocessor permanently. But only this 8255 is enabled, disabled only by the signal. If 0 is given in this pin, then only it will consider all other inputs. Suppose if the pin is 1, then the device is off. Whatever the remaining signal you are giving, the device will not accept. This is called the chip select. It will select the IC, enable, disable, like the CS signal is important here. Then we'll come to that group A, group B control. Here there is a control register, group A control. Group A control means it has a control of port A, then the upper port C. So 8 plus 4, 12 pins which is having a control. So these 12 pins, either input or output, we can set it up with the help of this group A control. The same way for group B control, we have a lower port of C, then the group port B. These 12 lines are controlled by group B control. That's what it is. Then the internal bus is 8-bit data bus actually, because all the ports are 8-bit. Then internal bus is obviously 8-bit size. The data from the processor also 8-bit. Then the internal communication, the data from external port to the peripheral to the microprocessor, everything is 8-bit wide only. Then the port A concern that all 8 lines, either you can configure input or output. So such a way as a group of 8 lines, you can configure input or output. That's possible through this port A. Then the port B also same. As a 8 group of lines, you can connect either input device or output device. But port C, we have separate controls. The port C upper 4-bit you can use as an input device. Lower 4 bits we can use as an output device. Likewise, you can configure. Then one more difference is that the port C alone we can use as a single bit port. Port C0, port C1, port C2, like a port C7 up to port C7, all 8 pins you can use as a single bit port also. Individually you can configure the ports. You can set and reset. That's what possible in port C alone. But port A, port B are as a group of 8 lines, we can have either input or output. So the setting up the device, suppose you are connecting a keyboard here, we have to set up the port as an input. For that, we need to write some data on the control register. Suppose you are connecting output device like LED on port B, then we have to write the control word to configure the port as output. So writing data on the control register, which is called the programming of 825. So programming in the sense there is no instruction, addressing or nothing here. Only varying the control register, 8 binary bits. If you are changing from 0 to 1, 1 to 0, you have different meaning. That's what meaning of 8255. So that's what about a programmable peripheral interface as a black diagram. Let's move on to the next one. This is control register. Here we have a 8-bit control register internally on 8255. Each and every bit has its own meaning. So by changing the particular bit, we have different meaning. That's what is listed in this. this content is called control word register. Control word register. So the D7 pin, if the D7 pin is 1 means which is IO mode, 0 means BSR mode. We have two operating modes of 8255. One is input output mode, another one is BSR mode. BSR mode means bit set reset mode. So if you are writing one, these pins are have different meaning. If it is 0, the remaining pins will have other meaning. So only the D7 decides which mode the operation of 8255 will be performed by this time. So whatever the meaning is given in here in the assumption of IO mode. If the D7 is 1, then the remaining D4, D5, D6 is mode selection. Mode selection in the sense we have 0, 0 means mode 0, 0, 1 means mode 1, 1x. 1x means 1, 0, 1, 1. For both the bits, it is mode 4. So three operating modes within that IO mode. So generally we have two mode, IO mode, BSR mode. Within the IO mode, we have three operating modes, mode 0, mode 1, mode 4. Then the next bit, D4 is indicated for port A. Suppose you are connecting input device on port A, you have to write as logic 1 here. Suppose you are connecting output device, write as logic 0. So here, see, look at the first letter itself, you can remember easily. Output means it is 0, input means 1. Based on this first letter, you can remember easily. No need to worry about that specification, how to remember. Then the D3 is for port C upper. Port C upper means PC4 to PC7. So only the 4 bits of port C can be input device or output device based on the data 1 and 0, what we are writing in this. Then comes to the D2, again it is mode selection, either it is mode 0 or mode 1. So actually here it is bit wrongly mentioned. Actually 0 equal to mode 0, 1 means mode 1. That's what it seems that different spell type 2 error. 0 means mode 0, 1 means mode 1. Then it comes to the D1, it decides that port B direction, either it is 1 or 0. Then the D0 means which is controlling that lower port of port C, PC0 to PC3, 1 means input, 0 means output. So this is the control word structure. Once again, we have to remember that if the IO mode is 1 on the D7, then only this meanings of D0 to D6. Suppose BSR, if this bit is 0 means will have different meaning, that we will look into it. See here, D7 is 0, then the remaining bits are like, remaining bits are bit set. Here these D6, D5, D4 are not at all used. Yes, don't care, you can write either 0 or 1. It won't get any effect on this mode. In this BSR mode, these three pins are not used. Then the D3 is D3, D2, D1. These three pins will decide that which port. BSR mode means a bit set reset of port C. So we have to select port C pin. PC0 means we have to write all 300. This is PC0, PC1, PC2 up to PC7. Suppose you want to set the PC7 means write logic 1 on this all three pins, then make it this as a 1. 1 for set, 0 for reset. So we have to identify which pin out of 8 in the port C, then that bit will be set or reset. We have to make logic 1 and 0 corresponding. That's what the BSR control word. So the previous one was IO control word. This is BSR control word. That's it. So in BSR control word, so you look at the operating modes. How because IO mode itself we have 3 modes. So each and every mode how we consider. The D7 bit is 0 means it is considered as a D7. This is applicable only for port C. No effect on IO mode. So it won't have any effect on IO mode. If it is 0 means IO mode will not be affected. Only the port C will be affected for this. Then if it is 1 means it is coming to the IO mode. In IO mode we have mode 0, mode 1, mode 2. Mode 0 is simple IO. All the A, B, C. All 3 ports you can either use as simple input device or output device. Simple means LED or any other device like you can use it. In IO mode, very simple devices, for example, LED switches. Because in LED and all, we cannot verify whether it is switch on or off. Simply, we will send logic 1, LED will be on, logic 0 off. So that's the mode 0. Mode 1 means we can have some handshake. Handshake means acknowledgement. Suppose we are sending data from one device to another device, whether that device received the data or not, that we can verify, which is called handshake IO. Handshake IO means here for port A or port B we can use for data, then the port C bits are used for handshake. So only A and B can be used for data transfer. Port C bits will be used as handshake, which means acknowledgement signals. Control signals will be transferred. Then the mode 2 is bidirectional IO. Bidirectional means at the same time data will be transmitted from transmitter to receiver, the vice versa, receiver to transmitter also possible. So here only port A can be used for bidirectional. Port B can be used either mode 0 or mode 1. Port C used for handshake. So this is the simple operating modes of 8255. So from this we can clarify 0 means BSR, 1 means IO mode. In IO mode we have 3 modes. Mode 0 is a simple IO, there is no acknowledgement. Mode 1, it is a handshake IO. Data can be transferred from one point to another point, but the reverse is now also possible, but only through the port C acknowledgement we can transfer. The mode 2 is bidirectional data transfer. With the help of port A, some lines you can transmit, remaining lines you can receive. Port B is not affected here. Port B is either mode 0, mode 1 will operate. The mode 2, only port A. Then the port C is used for handshake in both the things. So the mode 1 and mode 2, we can use only port A, port B for data transfer. Here the mode 2, simply we will use whenever we use transfer the data between two microprocessor, high-speed data transfer, that time we will use for mode 2. Likewise, any programmable device data transfer with the memory, then we will go for handshake IO. But a simple IO devices, we will use modes. That's it, the operating modes of 8255. So how the devices will be connected here? Look at here 8086. These are all the peripherals. This IO interface circuitry, which means 8255 here. That's what I meant here. Then now we will find out this. Find the control word set all are as output ports. Simple IO mode, all are output ports. That's what our condition. Let us do this for the sake of understanding. We will complete this. It will be clear. So I'll find out all as output ports. All output port means we have to go with mode IO mode. So set this as 1. Then look at this simple output mode. The modes are not the mode 0, mode 1, mode 2 is not mentioned here. So in this case, we have to go with the default mode 0, 0. So these two bits are 0, 0 because mode 0. If it is not mentioned, then go with mode 0. Then the D4 is port A. Look at here, all ports are output ports. So output means what here? This is 0, so make it 0 here. Then D3 also, here also output 0 means make it 0 here. Then D2 for mode selection. Again, this is printing mistake. This is mode 0 we are operating, so make it mode 0 because whatever the mode we are selecting, we have to select the same here. Then D1, D0, port B is also output. Then this is also output. So this is the programming for the given condition. All the 3 IO ports has to be set as output ports. So now look at this hexadecimal number for this divide into 4-bit chunk. 4 zeros are 0. Then 1 0 0 is 8421 form. It is 8. So the control word is 80H. 80H. So if you are transmitting 80H to 8255, it will configure all the ports are IO ports. That's all about control. That's all about programming of 8255. Let us move on to the next one. The next one is in the BSR mode. Find the control word to clear PC5. Clear PC5 means Look at the PC5 where it is PC5 means this combination 101 we have to make it 101 plus 5. Then we have to clear means reset, make it to 0 here. And then look at this word, this to be 0 because BSR mode means always 0. So PC5 clear, set and clear can be done only this. The bit set reset mode, we have to make it to 0. The remaining pins as your choice. Either you can have 0, 0 or you can have 1, 1, 1 or some bits are 0, some bits are 1. Whatever it is, that it doesn't make any difference in this. So for this configuration, it is 0. Then 1010 is 10. 10 means in hexadecimal 8. So it is 08 H, which is the control word for this given configuration, control word to clear PC5. That's all about 8255. So if you have any doubts and clarification, now you can comment. I will clarify and later. Thank you very much.